Kia ora and welcome to The Explainer. Today, we are taking a sledgehammer to a massive tech buzzword, AI reflection. Look, we hear a lot about AI getting smarter, but today we're completely bypassing the hype. We are going to strip this topic down to its absolute basic building blocks and rebuild it from the ground up using first principles thinking. By the end of this, you're going to understand exactly how modern AI thinks and, more importantly, how it corrects itself. Let's dive right in. So let's kick things off with a pretty massive question, one that really gets to the heart of how we view our technology. Does AI always get it right the first time? You know, it's incredibly tempting to think of AI as this magical and fallible brain. You type a prompt, press enter, and boom, out pops a perfect, flawless answer. But if we strip away the magic and look at the irreducible truth of the matter, AI is basically just a highly complex prediction engine. It's essentially guessing the next best word or line of code. And because it's guessing based on probabilities, it is absolutely fallible. It gets things wrong. It hallucinates. It misses the mark. Right, so let's look at the myth versus the reality here. The myth is that AI is a perfect oracle. But the fundamental reality, and this is our very first principle for today, is that AI makes mistakes. And just like any of us having a crack at something new, if it's going to make mistakes, it desperately needs a structured way to spot its errors and fix its own work. If we just accept the raw fact that an AI's initial output might be inaccurate or incomplete, we realize we can't just rely on a single-pass system. We literally have to build a mechanism for it to double-check itself before it hands the final result over to us. Okay, so what do we do about that? Enter this concept right here, the reflection pattern. Let's remove all the academic jargon for a second. The reflection pattern is simply a built-in feedback loop. That's it. It is an AI agent evaluating its own work and then using that evaluation to improve its response. Instead of just taking its first guess and running with it, the AI stops, takes a good hard look at what it just made, figures out what's wrong with it, and tries again. It is self-correction, pure and simple. Let's rebuild this concept step by step with a real-world analogy. Think of the reflection process like baking a classic kiwi pavlova. Step 1 is execution. You mix the egg whites and sugar and chuck it in the oven. This is the AI generating its initial output. Step 2 is evaluation. You pull it out and, well, it's a bit flat, or maybe it's weeping. You analyze that result. Step 3 is refinement. You figure out how to improve. Maybe you need to whip those eggs a bit longer next time or add a dash of vinegar. And step 4 is iteration. You repeat the process, baking a new one until it is absolutely spot on. The AI is doing exactly this, generating, analyzing, tweaking, and repeating until a stopping condition is met. And what we're looking at here brilliantly illustrates exactly how that flow works. You, the user, give the AI a prompt. The AI agent executes and creates an output. But notice how instead of that output coming straight back to you, the process loops back around. That right there is the reflection phase. The agent looks at its own output, assesses it against your original prompt, and then feeds those insights back into itself to try again. It's a continuous loop, progressively getting closer and closer to the actual goal before it finally delivers the finished product to your screen. But hang on a second. We really need to critically examine this. Is it actually a good idea for an AI to mark its own homework? Think about it. If you've just spent hours writing a massive report, you are probably the absolute worst person to proofread it, right? Because you have cognitive bias. You're just way too close to the project. You tend to read what you think you wrote rather than what is actually on the page. Well, AI can suffer from a very similar blind spot. If a single agent writes a piece of code and then evaluates that exact same piece of code, it might completely glaze over obvious logic flaws. Why? Because it's using the exact same thought process to review it that it used to write it in the first place. So how do we fix that from the ground up? The architectural solution to that exact blind spot is something called the Producer-Critic model. Notice how the single agent we saw before is now split into two entirely separate logical roles. You still have the prompt going in, but now it hits the producer agent first. The producer makes the output and then sends it over to the critic agent. The critic agent does the reflecting and sends the feedback back to the producer. We have essentially introduced a fresh set of eyes. Let's break down these two roles from first principles so it's crystal clear. The producer is your creator. Its sole responsibility is execution. It focuses entirely on generating the initial draft, whether that means writing a Python function or drafting a quick blog post. The critic, on the other hand, is your meticulous fact checker. It gets a completely different set of instructions, often a distinct persona like you are a senior software engineer reviewing code. The critic doesn't write anything new, it just takes a massive red pen to the producer's work. In tools like Google ADK, you literally set up one agent as a draft writer and a completely separate agent as a fact checker.
By separating these concerns, the critic remains totally unbiased and dedicated entirely to finding errors.
Let's ground this in reality and see how this builds up in everyday tech tests. Imagine asking an AI to write a blog post. Without reflection, you just get a first draft. It might be a bit clunky or repetitive, but with reflection, it writes a draft, critiques it for flow, tone, and clarity, and then rewrites it. Or what about writing code? Say, calculating a factorial in Python. An unreflective AI might just spit out a script with hidden bugs. A reflective AI writes the code, runs simulated tests, finds the errors, and debugs it before you even see it. And for summarizing a huge document, without reflection, it might miss key facts. With it, the AI actually checks its own summary against the original text to ensure nothing crucial got dropped. It completely elevates the AI from being just a basic text generator into a highly active problem solver. Now, to be completely fair and balanced here, it's not all sunshine and rainbows. Adding these reflection loops means adding some serious hard yakka for the computer. There are absolutely trade-offs we have to consider. First up, higher computational costs. Every single time the critic checks the producer's work, that's another call to the AI model, which costs money. Secondly, increased latency. It takes way longer to generate, check, and rewrite than it does to just generate a one-off answer. It is also highly memory-intensive because the AI has to remember the entire conversation history, the first draft, the critique, the second draft, the whole shebang. So as a general rule of thumb, this pattern is fantastic when quality and accuracy are paramount. But it is not ideal for time-sensitive applications where you just need a cheap, instant answer. I really want to highlight this brilliant point from our source material. This synergy transforms the agent from a passive executor into a purposeful system that adaptively works to achieve its objectives. When you combine this reflection loop with a memory of past conversations and a clear goal, you completely change what the AI is capable of. Think about it. Without memory, reflection is just a one-off correction. But with memory, the AI actually learns from its past critiques. It avoids repeating the exact same errors. It becomes a cumulative, adaptable system that actively works to solve complex problems, rather than just passively blurting out the very first thing that comes to its digital mind.
So, we've taken a really complex AI concept, stripped it down to the raw truth that AI makes mistakes, and rebuilt it step by step into a sophisticated producer-critic feedback loop. By separating the creator from the fact-checker, we've seen exactly how an AI teaches itself to be better. So here's my final thought for you to take away. How can you apply this step-by-step, first principles thinking to the next complex tech concept you encounter? Because when you strip away the jargon and look at the raw building blocks, even the most advanced tech out there becomes as clear as day. Thanks for joining me on this explainer, and keep exploring those fundamental truths. Catch you next time.